Okay, so in this video, we're going to look at creating common statistical graphs in the TI-83, 84. And the calculator can calculate a scatter plot, a line graph, a histogram, and a box and whisker plot. It can calculate two versions of them, one with and one without outliers. So let us look at each one of these examples in turn. So the line graph can be used to plot things like frequency polygons. The thing that you need to keep in mind is going to be that you need to make sure things are in order for the frequency polygon to work, though. Our first example is going to be a histogram. Now, for entering the histogram data into the calculator, some things that you need to keep in mind are that you can only enter up to 40 values into your TI calculator. So as long as the number of values you're entering is less than 40, then you'll be able to pull this off in the TI. Otherwise, you will need other kinds of technology like Excel or some other kinds of stats programs, Minitab or something like that. So our example is going to fit into the calculator, but it is worth keeping in mind that the TI is limited to 40 values. So the first thing that we're going to do is we're going to enter this data into our list. So we're going to do that by selecting the Stat button. And then from the Edit screen, we're going to select Edit and go in and enter this data into List 1. For the histogram, it does not matter what order you enter the data in. So you could read this data across the line, or you could read it down the column, whatever is easier for you to keep track of. The one thing that you do want to keep track of is to make sure that you've entered all of the data into the list and you're not missing any values. Because of course, if you miss values, then your graph will not be correct in the end. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 times 3, there's 30 values here. So when you get to the end of your list, if you are hovering over your last value, the screen should tell you L1 parentheses 30. It is the 30th value in the list. If your cursor is right below the last value, it should say 31 as the parentheses value, because that's the position in the list. So just, again, kind of keep that in mind. If you go back and you find out you've missed any values, you can just add them to the end. Now, once we have the data in the list, we have to go, we can escape out of the screen with second quit, and then we can go to the statplots function. So to get into statplot, we're going to select second, which is, again, the top left button on the main part of your keyboard, and then y equals, which is the one, again, on the left, right below the screen. And we're going to set the statplot settings for the histogram. So initially, everything, if you've never used this before, everything will look like they're off. So you're going to select Enter or press 1, because we're going to adjust the stat plot, the plot 1, for our first graph. You certainly can use other ones, but since this is just an example, we'll just use the first one. And when you are on the first line, you can put your cursor over here, over the off button. And if you press enter, it will turn it on, and vice versa. If you go over to, so when you get into that screen, you press 1, you get into this screen, on, off. If you wanted to turn on, put your cursor on top of on and press enter. If ever you wanted to turn it on again, or turn it off again, then when you're on the screen, you would scroll over to off and press enter. Whichever one is applied will be highlighted. So when it's on will be highlighted. When it's off will be highlighted. Then we're going to scroll down to the type line. And the type line, this is our scatter plot, this is our line graph, this is our histogram. These are our two types of box plots. This one has outliers, this one does not have outliers. And this last one is a cumulative one. Again, this is the one we're not going to use, but you can also do this, again, for the same kind of data that you could make a frequency polygon out of, you can make a cumulative line graph out of, a cumulative frequency graph out of. But we want a histogram for this example. So we're going to scroll over to the third thing over here and then press enter. And again, that will highlight it. Where are we going to get the sources of our data? Once you switch over to a histogram, the Y list is going to disappear and you're just going to have an X list. Here is where you're going to enter where the source of your histogram data is. Hopefully you put everything in list 1, and so you're going to specify list 1 here. Remember, to specify list 1, it's second 1. And then in the newer calculators, you will also have options for things like color coding your graph. You can feel free to play around with this in the newer calculators. In the older calculators, you won't have the color option, but you're free to leave this setting unchanged. It won't really affect the way that the histogram is calculated. Now, on the newer calculators, sometimes they will, especially the very, very new calculators, they may be able to do this for us, but typically we are going to want to specify a window adjustment so that we can make sure the graph displays appropriately. So we are going to need to set on our window screen the minimum value, the maximum value, and the class width so that this will calculate the correct value, the correct screen width for us, and the correct number of bins. So if the list is quite long, you can sort the list in order to obtain the minimum and maximum values. You can also just use the descriptive statistics function, and it will tell you the minimum and maximum values. But what you want to find out are essentially the range, and you obtain that from having the minimum and maximum. So again, this goes through the example of how to sort the data. Or as I noted, you can do the descriptive statistics to get these values. For our specific data, we find out that the minimum is 40 and the maximum value is 108. So when we set up our window, we are going to want to make sure that if it's on a standard window from -10 to 10, we're going to see nothing. So you would want to go back into your window list and specify a minimum of at least 40. I would say give it a 35 just so that you have a little bit of cushion. And then also the maximum value is 108. And again, I would say give it a little bit of a cushion. So maybe 110 or 115. Now to calculate the class width, we first have to figure out how many classes we want. How many bars do we want on our histogram? The rule of thumb generally is you want between 5 and 20. If you have a lot of data, you will use more. If you have a very little amount of data, you would use less. For this example, I'm going to use 7. And so to calculate the class width, you would specify essentially the range, the maximum minus the minimum, divided by the number of classes that you want. And in this case, I get around 9.71. Now, in general, even whatever your decimal place is, you generally don't want to round down because that will actually usually mean one more class unless this comes out to be an exact value. So here I'm going to round up to 10. You may want to round to 9.75 or 9.5, or that would be down. You would get an extra class. If you rounded to 9.75, you could probably get away with that. But I would just recommend in most cases, it's useful just to round up to the nearest integer, and 10 is probably fine. Now, if your data is not very well spread out and you get a very small decimal and you round up a lot, that may reduce the number of classes from 7 to maybe say 6. So you do sometimes have to play with this to get the exact number of classes. There is a rule of thumb. There's not like a hard rule that we must use 7 here. So it may not be a big deal if you're just doing an example. But if you're specifically being asked to get 7 classes, then you do have to be careful a little bit about how you do the rounding. Round up, but not too much. And you may need to play around with the rounding a little bit if you end up rounding up too much and then getting too few classes. Now, textbooks will often choose examples that they give them integer values. So class widths are typically chosen to mimic this, but the reality is rarely as nice as normal. So, don't overthink this, I would say, because it generally in the real world isn't going to work out to be nice and even. So when I go to the window setting, the suggestion is to set this to be a minimum value minus 0.5. Again, you can go a little further. You can go down to 35, give yourself a little bit more room. You may need to play around with the margins to see exactly what fits best on your screen. But you don't want to go to just the minimum value, because then you won't see the bar on the end of the leftmost bar and his histogram bar. And you also don't want to go just to the maximum value, because that will also give you just a little bit more. Now, the maximum value is a little bit more complicated, because you actually have to think about how many groups, how many bins you're going to have and how big those are. And so in this case, again, if you're going exactly to the maximum, you can go to just 0.5. But in this case, the maximum is actually going to be, I went a little bit further because it's a whole number of classes. So again, if you want to see the end of that last bar and actually see it on the graph, you do have to go a little bit past it. If you go 5 in either direction, the graph might be a little narrower, but you won't have to worry so much about like how many whole numbers of classes am I accounting for. And then finally, you may need to play around with the Y max a little bit. The Y min can be set to just barely under 0. So here it's about negative 1.5. The Y max is going to depend on how tall your bars are. And so that will depend somewhat on how much data you have. If you're figuring that you have no more than a count of 10 in any of your bins, Y max equals 10 should be okay. Again, you can only put 40 observations in your data set. So you might have to go to 15 or 20, depending on how narrow and tall your graph is. But you may have to play around with this a little bit in order to get it to fit. And then the tick marks are on the left are in units of 1 on this side. And the X scale here is marking the bin width. So this is where I would put how big my bins are. So 10 is how big my bins are. And for most of these other settings, you don't actually need to mess around with them too much. Here, the tallest bin, as I said, was 9. And so 10 is sufficient for the tallest class. You can also choose the calculator to choose for an optimal number of classes for you. To do this option, do zoom 9 for zoom stat, and then the graph will be adjusted to show all of the appropriate bins. Now, in this case, though, the graph here still has 7 classes. It does look a little nicer, but they're actually using these exact decimal places in order to get the minimum and maximum scale and the bin widths. So here they're using just 6 bins. And so they've specified 11.333. The problem here is the calculator is rounding down because this is 3333. And then it didn't quite make it into 6 classes. 108 is just a little bit short. And so it ends up actually being in a class all by itself. And so this is the danger when you round down even a little bit. It will put that last value in its own class. Now, if we wanted to then take this and calculate things like, descriptive statistics on the grouped data, on the histogram data, we have the original data, so we can use the raw values. But in principle, you would want to calculate the midpoints of the classes in order to calculate the estimate for those descriptive statistics. Now, another kind of graph that we can create are the box and whisker plots. Sometimes they're just called box plots. And they're also built from one variable numerical data. So we can use the same data for this that we did with the histogram. So you would need to enter the data, the same data we had in the previous example, into the list. If you've done the histogram example, it's already there. So there's two types of box plots that are available. One will just be calculated from the 5-number summary with no extreme values calculated, and the other one will calculate the extreme values, the outliers. So this simple one is constructed using just the minimum, the maximum, the first and third quartile, and the median. Now, we figured out the min and the max in the previous example were 40 and 108. To calculate the median, again, you can use the descriptive statistics function. It will output all of these values. Or you can do it manually by sorting the data and then selecting the middle value. And then if you have an odd number of values, it will be an actual data in the list, of an actual value. If, on the other hand, it's an even number of values, then you would average the two values in the middle. In this case, the 15th and 16th elements in the list. In calculating the quartiles, you would do the same thing. Essentially, you would split the data in half, the first 1 through 15 values, and then select, you would scroll through the sorted list, and you would select the one at the midpoint, which would be the eighth value. And if you're in the top half of the list, it would be the eighth value from the midpoint, I believe. But you could scroll through the list, through the sorted list to get these. I would recommend calculating the descriptive statistics and getting the 5-number summary just from that outcome. So we can get that obtained that way rather than sorting the data and scrolling through the list. We could then, from here, plot the box plot by hand, but we can also let the calculator do this for us, and we can read those values off the box plot. Now, we're going to also need to set up the box plot first. So we're going to go back to second y equals for the stats plots options. Here, since we've done the histogram, on is already selected. We'll still need to go to the type and scroll over to this second to the last option, which has the box plots without the dots on the end. The dots are the outliers. That's another step of the calculation. This is our simplest box plot with just those 5-number summaries. The list that we're taking the data from is still list 1, so we can leave that alone. And then we can press zoom 9, which is the zoom to the stat menu, stat function, and it will automatically set up our box plot for us. And we can see from the graph here that we have our box plot. This is our min, this is our max, this is our median, this is our Q1, this is our Q3. If you select trace, you can scroll through the values on the box plot and see the minimum, the Q1, the median, the Q3, and the maximum. The same trace function will let you scroll through the histogram bars in our previous example to see the count in each of our histogram and the value of the bins. Now, if you want to calculate the box plot with outliers, to do that by hand, we would have to calculate a bit more. We would have to calculate what's called the IQR, which is the interquartile range. Essentially, this is the difference between Q3 and Q1, so that middle 50% of the data. And then The 1.5 times the IQR is how much further past the quartiles you would need to be considered an outlier. So that would be below Q1 or above Q3. Now, in this example, if we have any values below 28.5, then that would be an outlier in the negative direction. If we were looking at a value greater than 120.5, that would be an outlier in the positive direction. You can also calculate extreme outliers using 3 times the IQR, but since we don't have any regular outliers in this example, then we don't have any extreme outliers either. Now, because of that, when we select this other option, this fourth option from our list, this under stat plot, the graphs will look exactly the same for this data because there are no outliers. But if there were outliers, you would get these dots extended beyond the farthest whisker, which would stop at the last value before the final outlier. And so you can, if you want to see what this graph is going to look like, let's go back into the list and replace our minimum value with 22 instead of 40. Leave all the other values the same. And then what you'll get is our two graphs will look a little bit different. The fifth option, the second from the end that we were looking at earlier, will look like this. The whisker will extend all the way down, and you can see it's much longer on that side down to 22, whereas in that fourth option with the dots, it will only extend down to the next previous value, not the minimum, but the value that is the smallest before it's considered an outlier. And then the outlier will be plotted as a separate dot outside the screen. Now, for this option, you will have to select how you want that outlier to display. The default is as a square, but you can also select a plus sign, a smaller filled in dot, or just a little teeny tiny dot. So again, you don't have to change this, you'll just get the square. But there are these other display options. The mark will come up. It won't come up on the regular box plot with no outliers, but it will pop up when you select option 4 for the box plot with outliers. And again, you can use trace to scroll through and see what those values are, what the outlier values are. Now, so far, the histogram and the box plot, we've only been essentially looking at one variable data, just one set of values in a list. In our second example, we're going to look at a frequency polygon, which is essentially a line graph. And here we're going to specify values in this case, ages in our first column, and then we'll specify frequencies in our second column. Now, this data is a little outdated because it hasn't been updated with like the last 3 or 4 presidents. That Reagan used to be the oldest and he's not anymore. But given that the first, say 44 presidents or whatever, we have the frequencies, or 43, maybe it's 43 presidents. We have the frequencies, the number of times someone of age 42 has been elected president, age 43, and so forth, all the way down to, again, Reagan's last inauguration was when he was elected at 69. Now, if we enter the data into the calculator, we're going to put the ages in list 1 and the frequencies in list 2. And then, again, you can enter this by selecting stat and then edit. If you need to clear the data, scroll up and then hit clear. Don't hit delete, hit clear, and then enter, and it will delete your list for you so that you can type over it. And then over in L2, again, you would enter the frequencies. If you need to clear the list from a previous calculation, you do the same thing. Now, To set up the line graph, we're going to go to second and then y equals again to get into stat plot, and then enter to enter plot 1, or scroll down to whatever other plot you would prefer to set up. And then we're going to scroll down to the type, and we're going to select this second option, which is the line graph. It's going to ask for the X list and the Y list. The X list is the values that were measured, and the Y list are the frequencies. And then you can just select zoom stat, which is zoom and then the 9 key, and it will automatically adjust your graph to fit all of the data. You can also adjust the Y minimum under the window if you want to see the X axis. Sometimes, depending on what your frequency values are, it will set it above 0, and then you won't be able to see the X axis at all. And so you might want to bring it down so that you can see, bring the minimum down a little bit so that you can actually see the axis. Anything outside the range of the data will be treated as 0. And again, this would be essentially our frequency polygon. That's what it looks like, some kind of weird shape, right? All right. And then finally, the last type of graph that we want to enter is our scatter plot. And for the scatter plot, we're going to need to enter data into 2 lists. So in this example, we're looking at the relationship between 2 variables related to soil quality and plant growth. And so we have this example data. To create a scatter plot by hand, the process is similar to a line graph, except you would only plot the dots and you would not connect them sequentially. But here we would just plot the dots, and that's what we're expecting to get from our graph. Now in the calculator, under stat, we're going to enter the data. And again, X will go in list 1 and Y needs to go in list 2. This order of what the X values and the Y values are matters for these examples. So make sure that you're entering them correctly. If you switch them around, we're going to need to switch them around when we plot our graph. So it's best to enter X in list 1 and Y in list 2. Now to set up our stat plot, we're again going to go to second Y equals and set up plot 1. And then we're going to, the scatter plot is the default option. It is the first option in the list. We're going to use that more often than we probably use some of these other ones. Once you've entered the data into the list, again, X list is list 1, Y list is list 2. If you're using other lists, make sure that you update those. And again, like with the box plot, there is a mark option. You can change that to other kinds of marks. The default works perfectly fine in most cases. It may depend on how much data you have, though. If you have a lot of data, you might want to use something that takes up less space on the screen so that you get a little less overlap on your graph. And then when you're done entering all of this information, hit zoom 9 to let the stat plot, the statistical data readjust your window for you so you don't have to do it manually. And you will get a scatter plot that looks like this. So this is just, there's a dot everywhere. There was a pair of X and Y values from our data. Now we'll save actually drawing the regression line on for another video, because that's going to require another step of calculation, not just graphing the data, but actually calculating the regression line and then entering that on top of this scatter plot. So for now, we'll just leave it at just the scatter plot.